very recently we've been working on conformational analysis. Very, very simple compounds that people think they know a lot about. In my view, the textbooks do not give the whole story. And one of the things we found out, for example, which is rather amusing, is that when we studied succinic acid, a very simple molecule that you wouldn't expect anything surprising from, that using NMR, we found that the unionized acid in water was about 85% gauche. And so then we wanted to study the monoanion. And of course, the monoanion would be expected, and this turned out to be an enormous problem later on with referees, to form a tight hydrogen bond because you have a negative carboxyl group and you have a carboxyl on the other side that can conjugate with that. And it turned out that it gave less gauche than the unionized acid. And that was very surprising, and I guess of all the papers I've ever submitted for publication, that was the hardest one to get published because referees just didn't believe it. So we took 2 or 3 years and patience by Marianne Fox before we finally got that paper in. And then we continued on this vein. We decided to do something that hadn't been done before really very much, is to measure conformations in other solvents. And one of the most important ones of those besides water was the MSO. And so we measured the acid, and it acted more or less like it did in water. We measured the monoanion, and it formed a beautiful strong hydrogen bond. And then we did the dianion. And it turns out that the dianion should have had repulsion between the carboxyl groups and gone linearly out straight, and it didn't do that. It turned out to give a lot of gauche, and we found that when we did it in tetrahydrofuran, that it was actually up around 60% gauche. And that means that the carboxyl groups that are negative are getting close to one another. And that is, you might call a physical no-no, but in fact, we're quite happy with that. We actually have an explanation for it. It's supported by quantum mechanics and things like that. And so that was very exciting, and that's been done just in the last 2 or 3 years.